Oh yeah, here we go, video 2, lesson 6. And we're gonna get a close look at how to integrate when our bounds are going to negative infinity and positive infinity. Oh my word. Well, the question remains, does this converge or diverge? And here's the graph of that. Looking at it, no, I don't know. We'll have to see what happens. But the number one idea here is that we have to take, count them, 1, 2 limits, because we're gonna go to negative infinity and positive infinity. So I have to split this thing up. So I take the limit as a goes to negative infinity. I'm gonna work from left to right on this thing, from a to 0. Now you could technically split this integral anywhere you want, but I think it's more convenient to split it at 0. It's easier to evaluate at the end. So if we have the choice, we use that. And that's of the original function, cool function indeed, plus the limit as b approaches. You have to pick a different letter there because you can't simultaneously approach negative infinity and positive infinity. We split it at 0 and then we go to b, which is going to infinity. All right, so that's the most important conceptual part as we split that up. Now, let's take a look at what this means. Now, just as a word to the wise, if this left-hand integral diverges, then the whole thing diverges. You don't even need to check the one on the right. Right? If one piece of an improper integral diverges, the whole thing does. If this converges, we have to go and check that one. If they both converge, then we add our values together. So that's our plan. Let's do it. So we've got the limit as a goes to negative infinity. Now, you know what? Before I keep that limit coming down, I'm going to show you how to do this just with normal old u substitution. So we handle this like we would any other integral. I don't include the u substitution with the limit. I'm just going to integrate it, find the normal antiderivative. And so that's going to be u equals minus x squared, normal old u substitution, du equals minus 2x. So I'm going to put in the minus 1/2 and the minus 2 so that we get minus 2x dx. So that gives me the integral of minus 1/2 e to the u du. And that integral is equal to minus 1/2 e to the u, which is e to the minus x squared plus c. So there's our antiderivative. So we carry that down and use that in our limit. So I've got the limit as a goes to negative infinity of, now we've got our antiderivative that's going to be of minus 1/2 e to the minus x squared. I got a little ahead of myself plugging in infinity. Evaluated from a to 0. All right, so we're going to do that one first. So we take the limit as a goes to negative infinity of, and I'm going to get rid of that negative exponent. It'll make the evaluation a little bit easier. That's going to be 1 over 2 e to the, and then it's just a squared, right? You're plugging in a. Ooh, that's our second value actually. We're plugging in 0 first, technically. So to the 0 minus a minus 1/2, and then we're going to put that all over e to the a squared. Again, we're plugging in that a value second because it comes second in our boundaries. So let's evaluate this. So negative 1 over 2 e to the 0, that's very simple. That's negative 1/2. When you evaluate the limit as a goes to negative infinity, think about it this way. You've got, well, basically a plus 1 over 2 e. Now, when you square negative infinity, it goes to infinity. So it's e to the infinity. So this whole thing is infinity. That's 1 over huge, which is 0. So I get negative 1/2 plus 0, which is equal to negative 1/2. So therefore, this integral converges. And we get that is what it converges to. Now the question is, does this also converge? Well, let's see. So now we're going to do it separately here. We already have the antiderivative. It'll be the same thing as what we got on the left. So it's a limit as b goes to infinity of, and we get the antiderivative, which is negative 1 over 2e to the x squared, evaluated from 0 to b. And so what we're going to do again is we're going to plug in our values. So I've got the limit as b goes to positive infinity. We've got negative 1 all over 2e to the b squared, plus, because it's going to be minus a minus, so that's plus 1 over 2e to the 0. Well, now, let's think about this. When we plug in infinity, you essentially have negative 1 over 2e to the infinity squared, which is infinity, plus e to the 0 is 1, so that's plus 1/2. So this value here goes from negative 1 over infinity, which is to 0. So it's 0 plus 1/2. So that also converges to 1/2. And negative 1/2, the area of this side, plus positive 1/2, the area of that side, what they converge to is equal to 0. Which makes sense. It looks like each of these are going to finite values, and opposite finite values added together equals to 0. All right, that's it. A short video Nonetheless, an important one. When you have two different infinities, you need two different limits. And remember, if one of the infinite limits, right, diverges, then you don't have to check the other one. In this case, the first one did converge, so we had to check the other one, and lo and behold, both converged. All right, I'll see you in the next video. Peace.